So why do we need the voltage for electricity, and how is that related to electrical charge and energy in the supply? So here's our basic unit of charge, the electron, which is negative and obviously is contained in the outer shell of atoms. You need this number of electrons to make up our basic unit of charge, which is the coulomb in physics. So we use coulombs, which is millions and millions of electrons. And even if you've got that number of electrons, you're not going to have energy unless you give it some potential. So I've got a sort of fuel gauge here for our coulomb of charge. And as it gets charged up to 3 volts with potential, or fully charged, say for 6 volts, then that's it now, brimful of energy, and it's now got 6 volts of potential. So if we put it on the circuit, here's our power supply or battery with 6 volts there. As the charge moves through the power supply, it charges up from 0 to 6 volts. And then as it goes around the circuit, as it's going around the wires, it actually doesn't lose any of that energy in the conductor. So it's still got that 6 volts for the coulomb of charge there. As it progresses through the wire, the resistance of the wire converts that electrical energy to heat energy, and so it progressively loses that energy. Until it's halfway through the circuit, I've got 2 equal resistors here, so that's used 3 volts of energy because it's gone through 1 resistor. As it goes through the second resistor, it uses up the other 3 volts and then heads back to the supply. So we've got 3 volts across there and 3 volts across there, equal resistors with an equal split of potential. So this time we'll use it with 2 different resistors. If this has got a particular value of resistance and this has a double, that could be 10 ohms, that could be 20, or that could be 20 ohms and that could be 40 ohms. So again, we charge up the with voltage, so we've got 6 volts for that coulomb of charge. Again, it goes through, but this time as it goes through, it loses only 2 volts worth of energy for that charge, because it's only had a small resistor to go through. But through the next resistor, there's more energy has to be used because it's more resistance. So it uses up 4 volts of that potential and then finally gets back to the supply. So what you need to know is that the potential difference, or the voltage of a supply, is the measure of the energy that's given to the charge carriers in the circuit, and also that as a charge goes around a circuit, then the bigger the resistance, the more energy is required, so the bigger the potential drop, which helps to explain in voltage dividers why you have more voltage across a bigger resistance.